Good afternoon, everyone, especially to you, sir. Today we will discuss about the key terms in chemical thermodynamics, including system, surroundings, internal energy, enthalpy, entropy, Gibbs free energy, heat, work, temperature, pressure, and spontaneous process. So we have key terms in chemical thermodynamics include enthalpy, symbol niya is H, internal energy, symbol niya is U, entropy, symbol niya is S, and Gibbs free energy, symbol niya is G. So nasa mga units such as joules is for energy, joules per Kelvin is for entropy, and joules per mole for Gibbs free energy. Other important concepts are heat, or symbol niya is Q, work is symbol niya is W, temperature symbol niya is T, and pressure symbol niya is P, which use units like Kelvin or K and Pascal or PA.
So, first, we have a system. The system is the part of the universe being studied. So, a system is the part of the universe that we are studying or focusing on in an experiment. So, it can be anything new, like a chemical reaction that happening in a test tube, or water boiling in a pot, or even our own body during exercise. There are three main types of systems in thermodynamics. First, open system. An open system can exchange both matter and energy, like boiling water where steam escapes. So that's the example of the open system. Second, a closed system. A closed system can exchange energy but not matter. Example, like a sealed soda can, so that's a closed system. And the third one is isolated system. An isolated system cannot exchange either matter or energy. Example, a thermos bottle with a hot coffee inside. So that's the three main types of systems in thermodynamics. Understanding what the system is helps us identify where energy changes occur and what part of the process we are observing. Second is surroundings. Surroundings is everything outside the system. The surroundings are everything outside the system that can interact with it by exchanging energy or matter. Example, when you boil water, the surroundings include the stove, air, and the kitchen. So basically, everything outside and the pot. So together, the system and its surroundings make up what we call the universe and thermodynamics. So the surroundings plays a big role because they affect how energy flows in and out of the system. And it can influence chemical and physical changes. Third is internal energy, which symbolized by U. Internal energy is the total energy contained within a system, including kinetic and potential energies. Internal energy is the total energy contained within a system. It includes two main types of energy. First is kinetic energy. What is kinetic energy? So, the kinetic energy is the movement of molecules. The potential and second is the potential energy. So the potential energy is the energy stored in the chemical bonds. So example, when you have a cup of hot coffee, so the fast movement of its molecules is called kinetic energy, but the part of the coffees is internal energy. So internal energy helps us understand how energy is stored, transferred, or used within a system using physical or chemical changes. Fourth is enthalpy, which is symbolized by H. Enthalpy is the total heat content of a system calculated as H equals U plus PV. So enthalpy is the total heat content of a system at constant pressure. It combines the internal energy, or U, and the energy needed to make a space for the system given by pressure times volume, or PV. Sample: when ice melts into water, heat is absorbed by the system. So, meaning it is endothermic process. And when a candle burns, heat is released, meaning it is an exothermic process. Enthalpy helps us measure how much heat is absorbed or released in chemical reactions, and it is useful in studying fuels, cooking, and energy systems.
Okay, let's proceed to the other terms in the chemical thermodynamics. The next one is the entropy, symbolized by S. Entropy measures the amount of disorder or randomness in a system. So it means the higher the entropy, the more disorganized the system is. So another example is melting the ice. So when ice melts into water, entropy increases because the particles become more spread out and random. So we can easily identify the difference between enthalpy and entropy because enthalpy is about the total heat of a system, while the entropy is about the measurements or the arrangement in the system. Next is the Gibbs free energy, which is symbolized by G. This is the energy available to do useful work in a system. It helps us determine whether a chemical reaction will occur spontaneously or not. If the Gibbs free energy is negative, the reaction happens naturally without external energy put. On the other hand, if it's positive, the reaction needs extra energy to occur. It's widely used in chemistry and biology to predict reaction behavior and energy efficiency. Next is the heat, symbolized by Q. Heat refers to energy transferred between a system and its surroundings due to a difference in temperature. When heat flows into a system, it increases the system's energy, while heat flowing out decreases it. Heat transfer can happen through conduction, convection, or radiation. It plays a key role in chemical reactions, phase changes, and many real-life processes like cooking or engine operation. Next is the work, symbolized by W. Work is the energy transferred when a force moves an object over distance. In thermodynamics, it often occurs when gases expand or contract in a container. For example, in an engine, gases do work by pushing pistons to move vehicles. Work and heat are both forms of energy transfer that change the internal energy of a system. Next is the temperature, which is symbolized by T. Temperature measures how hot or cold something is, or scientifically, it represents the average kinetic energy of the particles in a substance. The higher the temperature, the faster the particles move. It affects how fast chemical reactions occur, how substances expand, and how even states of matter change, like ice melting into water. The pressure symbolizes the P. Pressure is the force exerted per unit area, often caused by particles colliding with the walls of other containers. In gases, higher pressure means particles are moving faster or are more tightly packed. Pressure is crucial in studying gases, engines, weather system, and even human respiration. So to summarize this information, thermodynamics uses these terms, which is the system, surroundings, internal energy, enthalpy, entropy gives free energy, heat, work, temperature, and pressure to explain how energy and matter interact in a physical and chemical processes. Thank you for listening. I hope this helped you understand the key terms of thermodynamics more clearly. My name is Judivine A. Tirante,
And I am Bernadine S. Maestre.
and this is our presentation.